Okay, so once you have the transform parent asset, you will have the rotate script as well as the transform child script. So let's go over both of those. The first of the two, rotate script, can easily rotate an object in runtime through the inspector window, as you see here. If you wish to rotate an object about one of its local axes, then all you have to do is click the As Local Vector. If we wanted this object to rotate counterclockwise to give a cool spiral effect, we would just have to see that we need to rotate it about its local y-axis. Enter in 1 and give it a speed. Let's see how it looks. Okay. Since it is rotating clockwise and we want it to rotate counterclockwise, all we have to do is put a negative value in the speed and it will reverse. If we want it to slow down, we could just decrease the speed. Perfect. Okay. Now on to the transform child. You can see here that the new parent relation matches the rotational properties of the default parent relation given to us by Unity. When you have the transform child script and you append it onto the child, as so, I believe this is the child, yes. All you have to do is give it a parent object, planet B, and drag it into the inspector window. Here, under parent. If you want the object to move with that parent, let us take the rotation off of this object here. If you want the child to move with the parent, all you have to do is keep the move with Boolean statement checked, and it will move with the parent. If you do not want it to move with, just uncheck it. Go. Okay. Let's put this rotation back on. And check move with once again. If you want the child to stop rotating with the parent, you can just unclick this and bang, it stops rotating with the parent. You can see here that the child rotates so that it constantly faces the parent from where it started. If you want this to stop and have it keep uniform orientation, you can just unclick Rotate Child. And now, it will keep facing the way it faced when you unclicked Rotate Child. Now let's look at what the multiplier does. Okay. If these all had a uniform multiplier, let's give these all a value of 1. And press play. We will see that they all rotate around the sun parent object at a uniform rate. You can draw a line between that intersects all of the planets at every single given time. Now, if we Control Z some of these so that they have different values, let's see what happens. Keep in mind that all of these planets have the sun as a parent. So when the parent rotates, that rotation will affect each of these planets differently. For example, this planet right here has a multiplier of 1, which means it rotates exactly how the sun rotates, just like in the earlier examples. However, a planet with a higher multiplier will rotate more with every rotation of the sun. And these objects with a slower speed than 1 will rotate slower with each rotation of the sun. Keep in mind that the transform child script does not impact scaling. This is because the scaling feature would be way too slow and would compromise the effectiveness of the script to work in a hierarchy like such. Here we have a parent, a child of that parent, and a child of that child. You can see that even though they are all in the same hierarchy, in the scene, we have a parent relationship. Let's see how it goes. Perfect. So, some extra things to note about the transform parent. It was built with the classic parent-child relationship in mind. So the parent's transform is essentially absolute. Nothing that happens to the child will affect the parent's transformations in any way. Unlike the default parent relationship, where if a child's collider is hit, then it will stop the parent as well. If a child's collider is hit in this case with our script, it will simply continue to phase through the object. Another thing to note is that because the script utilizes the local values of the parent object in order to make the transformation onto the child object, it is very important that the parent and child are in the same hierarchy. Now, this is because the local position for, let's say, this parent-child hybrid has these values as a local object because it does not have a parent. Because the child's position and location are based upon these local values, the transformation will change if, let's say, we place it under the sun. Here we have the different local values, which will affect the transformation of its little moon. Let's see how that looks. Right. Probably not what we wanted. So, it is very important for the objects here to stay in the same hierarchical level. This can be used, of course, to our advantage if we need it. Well, that is all I have for you. Enjoy this asset, and I hope you have a great day.